Welcome back, everybody. In this video, we'll continue working on section 2.2 in our look at graphs of linear functions. In this video, we're going to start off by looking at parallel and perpendicular lines. So first of all, I'm going to assume that you know what it means for two lines to be parallel. Basically, the two lines point in the same direction. They go in the same direction, they never meet. For perpendicular lines, they intersect at a right angle. So parallel in a way is easier because it's going to fit your intuition some. If you have two lines that are parallel, it should make sense that they have the same slope, so that the slope of one line will be parallel to the other if and only if the two lines are parallel. If you have, that's a part of the statement here, two lines are parallel if they don't intersect, the slopes of the lines are the same. Here's an equation of f of x, that's m1x plus b1, and g of x is m2x plus b2. The m1 and the m2 are the same. So that's kind of basically a long-winded way of saying that if they're parallel, the m1 has to equal the m2. The two slopes are the same. For perpendicular, it's a little bit trickier. The picture should be clear. The two lines intersect at a right angle, but as far as algebraically how to tell if they're perpendicular, the slopes are negative reciprocals. So we're going to talk about that a little bit. Okay, so meaning that they're negative reciprocals means, well, first of all, if they're negatives of each other, so 4, -4, 2, -2, they're negatives of each other, but not only that, they have to be reciprocals as well. So examples would be 3 and -1/3, 4/5 and -5/4. So not only have we formed the reciprocal, but also they're opposite in sign. 11/8 and -8/11. Opposite in sign, and then additionally, they're opposite in sign and also reciprocals of each other. Another way of looking at it is their product equal to -1? That is 4/5 times -5/4 is going to equal -1. That's how to tell if they're negative reciprocals. Some anti-examples would be 7/8 and 8/7. Okay, those are reciprocals of each other, but they are not opposite in sign. -3/7 and -7/3. Okay, those are reciprocals of each other, but they're not opposite in sign. In order to be perpendicular, they have to meet both kind of criteria. They have to be opposite in sign and also reciprocal. The opposite in sign part is pretty easy to see from the picture. If we have a line with positive slope, it makes sense that one perpendicular to it will have to have negative slope. Okay, so then the fine print for that, if it turns out that the y-intercepts are the same and the slopes are the same, the lines are coincident. That is, they're really the same line. So we don't need to say a lot more about that. For perpendicular, if we've got two functions, m1x plus b1 and m2x plus b2, they're perpendicular if the product of their slopes is -1. Or equivalently that the slope of one is -1 over the slope of the other. This is the negative reciprocal statement. Okay, so let's try this. We're going to decide if y equals 2x minus 3 and x plus 2y equal 14, if they're parallel, perpendicular, or neither. Okay, so how to do that? We just need to take a look at their slopes. So for the first one, y equals 2x minus 3, what's its slope? Slope's 2. Okay, for the second one, x plus 2y equals 14, there's an easy way to do this and a hard way. The hard way would be to pick out an x, solve for y, pick out another x, solve for y. Now you've got 2 points. Now you use the formula for slope to calculate the slope on those 2 points. That's the hard way, or more time-consuming way. You're better off rewriting this thing so that the y is isolated. So we'll solve for y. in just a couple of steps. Okay, our y will be -1/2 x plus 7. Now that this thing is in slope-intercept form, we can tell what the slope on this one is. It's -1/2. Okay, if we have one that has a slope of 2 and the other one has a slope of -1/2, then that means that the lines are perpendicular. Okay, 2 and -1/2 are negative reciprocals of each other, and if we multiply them, we're going to get -1. All right, so I'm going to go ahead and draw the graph of these two. So let's see that. All right, so let's make these two lines, the graphs of the two lines. So one was y equals 2x minus 3, and then the other one, x plus 2y equals 14. All right, so those two lines look like they're perpendicular, all right? So that's, looks like that'll do it. So there's the graph of our two lines. All right, so we've seen that the two lines are perpendicular. In doing the graph, it looks like the two lines cross at the point 4, 4. But I think it would be fun to go ahead and check that that's true. So in doing this, what we're going to do is solve a little system of equations. So there's a variety of ways you learn how to do that, usually in intermediate algebra. One way to do it that'll be pretty straightforward in this case is to use substitution. So let's try that. Our second equation is x plus 2y equals 14. This is an equation in both x and y. So what we want to do is substitute. We have in our first equation an expression for y, which is 2x minus 3. So we're going to replace where we see a y, we're going to replace that by 2x minus 3. This will give us an equation in x that we can solve pretty easily. So let's do that now. All right, so I've rewritten our second equation, x plus 2y equals 14, and I've substituted in that second equation, it says y here, but we know from the first equation that y is 2x minus 3. So this gives us an equation just in terms of x's. So let's go ahead and solve that. Okay, so it looks like the x is going to equal 4. Once we have the value for x, we can substitute that into either equation to get us the value for y. So the first equation, y equals 2x minus 3, is already solved for y. So let's go ahead and replace our value of 4 for x in there. And then we can calculate that. That looks like it's 5. So the x coordinate's 4, the y coordinate's 5. So that looks like where those two lines cross. All right, so that was not part of the original question. I just thought it would be fun to go ahead and put that in there. In the next example, we're back to writing the equation of a line, but this time we're given a point that it passes through, and we're also told that it's supposed to be parallel to some other line. So this in a way gives us some slope information. So if it's supposed to be parallel to this line, I know that it should have the same slope as whatever this one does. So where we'll start is figuring out the slope of this line that we are given. And as we've discussed earlier, the easiest way to do that is to take and rewrite that equation in slope-intercept form. And so let's do that. Okay, so I've subtracted the 5x from both sides. That left us with -3y is equal to -5x plus 10. Dividing out that -3 will give us +5/3 x minus 10/3. So from here, we can see that the slope is 5/3. And then the line that we are making is supposed to be parallel to it. So its slope should be the same. So then we'll have y equals 5/3 x plus b. where now, of course, we need to know what the b is, and we'll get that by plugging in our 0.21 into the equation. So when y is 1 and x is 2, we'll use that to solve for b. So 1 is 10/3 plus b. 1 is 3/3. 3/3 minus 10/3 will be our b. So b is -7/3. So that's not the final answer. We're supposed to come up with the equation. That was 5/3 x minus 7/3. Okay. We had a line that we were given. We wanted to come up with a line that was parallel to that line, but passing through this other point. Okay. Variation on that question. This time it's supposed to be perpendicular. So we want to find the equation of a line that's perpendicular to a given line, but passing through the point -3, 2. So the one that we're supposed to be perpendicular to is this y equals 4x minus 3. Y equals 4x minus 3. Its slope is 4. So ours will need to be -1/4, the negative reciprocal. Now this kind of is degenerated into a question where we're given a point and slope and we want the equation of a line. So let's go ahead and do that. So y will equal -1/4 x plus b. And then we'll put in our 2 for y. And then our -3 for x. And use that to find b. Okay, 2 is 8/4. And so that means that our b has to be 5/4. Okay, so then putting together the parts, our equation will be -1/4 x plus 5/4. Okay, so that's how that looks. Okay, let me go ahead and add some graphs to this. All right, welcome back. I went and put the graphs on for each of these problems. The first one that we had done was the one about parallel. So in green, you'll see the graph of 5x minus 3, y equals 10. And then the line that we produced in purple, y is 5/3 x minus 7/3. And sure enough, they do look parallel, so that's good. And then we had gone on to find the equation of the perpendicular line to 4x minus 3, but passing through the point -3, 2. So our 4x minus 3 shown here in green, and then the one we came up with, -1/4 x plus 5/4 shown in purple, so, or black rather. So I did want to point out though that when I first did it, I thought I had messed up because the graph looked like this, which definitely doesn't look perpendicular. But you want to make sure and double check that your axis is zoomed square so that the axis scaling is the same. Here, the horizontal axis, it looks like 0 to 2, and then on the vertical, it's 0 to 5. So that is messed up. But then, of course, it's correct on the upper picture. So it looks more perpendicular. So the point there is that the way your axis scaling can affect how your drawing comes out. All right, so for the next and last example for this section, I wanted to do a story problem. And so here it says a cell phone company offers 2 plans for minutes. Plan A, you can pay $20 per month and then $1 for every 100 texts. So of course that will be a penny per text. And then plan B is $50 a month, so it costs more per month, but the texts don't cost anything. It says free unlimited texts. And then the question is, how many texts would you need to send per month for plan B to save you money? So let's check. So what I want to do is come up with a function for each of the 2 plans, and then we're going to compare them. So I'm going to, instead of using f for function, I'm going to have my functions called a and b. Usually we have our functions called f or maybe g, but when we start doing more applied problems, story problems, then we're more likely to see functions called other things. So for plan A, the input is going to be a number of texts, and we'll call that T for texts. The input is some number of texts, and then the output is going to be the cost. I'm going to call that A for plan A of T. And it's $20 a month. That's going to be independent of how many texts there are. That is, if you had 0 texts, A of 0 should still be $20, and that will be our y-intercept. And then it goes up $1 for every 100 texts, or 0.01 per text. So if you sold, or if you had one text, sorry, sold, I don't know where I got that. If you had one text, that would be $20 plus 0.01 times the one text. So we're going to take $20 and add on a penny times the number of texts that there are sent during the month. So our A of T will be $20 as a flat fee plus 0.01 T. That will be our function for A of T. Okay, and then for B, it's going to be $50 a month with free unlimited texts. Okay, so for B of T, it's going to be a flat fee that is independent of the number of texts. It'll be constant at $50 per month, regardless of how many texts you send. So our B of T will be 50, and then if you really want to be like math looking about it, you can say plus 0T, because each text is costing you nothing. But of course, it's just simpler to say, okay, B of T is equal to 50. All right, so there's our two functions, A of T and B of T. And so our question was, how many texts would you need to send per month? That is, what would be the T to make it so that B is cheaper? Because of course, B costs you more per month, right? A is cheaper per month, but then you're paying for each text. B is more per month, but then you get free text. So at some point, B is going to be cheaper if you send a lot of texts. So we want to know when, that is, for which T, will B of T be less than A of T? Okay, so we want to find that out. So B of T is 50, and then A of T is 20 plus 0.01 T. So a little linear inequality to solve. Let's subtract 20 from both sides. That will give us 30 is less than 0.01 T. And then multiplying both sides by 100, that will be 1,000. T has to be greater than 3,000. So if you send more than 3,000 texts, B will be cheaper. Okay. All right, and so that's how that example plays out. All right, so I went ahead and added the graph for this. We had come up with a function A of T, which was 20 plus 0.01 T. In putting it on the computer, it pretty much needs the input value to be X, so I've used X's instead, and I've called both functions Y. Okay, but hopefully that's okay. So this is our function A of T down here, and up here is our function B of T. And so you can see where the two lines intersect. That is where what's called the break even occurs. If your number of texts, which is on the horizontal axis, is higher than 3,000, A of T will be bigger than B of T. And of course, as a consumer, you want it to be less. So that's why if your number of texts is higher, you want to choose B of T. If your number of texts is higher than 3,000. But if your number of texts is going to be less than 3,000, it's cheaper to go with A of T. A of T is less than B of T. And of course, if it happens to be exactly 3,000, it doesn't make a difference. All right, so there's that. A couple of the things I wanted to point out is when you're drawing the graph of something like this, if you're doing it on the computer, you'll need to modify the X and Y scaling because they're just so much different values. The vertical scale only goes to 60, the horizontal scale goes out to 4,000. So if you just draw this and leave the, don't adjust the axes, the lines will look practically coincident. The other thing I wanted to mention is that I wanted the graphs to just start at 0 because it didn't make any sense to have negative texts, a negative number of texts. So that's the part in curly braces. We're just specifying a domain, and that is that we're requiring the x's to be at least 0. But that's just kind of minor stuff. The big part was knowing which function is on top. It tells us basically which one is the better deal for you as the consumer. Anyways, so that takes us to the end of section 2.2. Let me know if you have any questions, and as always, have a great day.